In this video, we're going to be talking about a point moving around a circle at a constant speed. First, we're going to be building the parametric equation. That will be a baseline for all of them to come. So let's take a look at what we have. Well, we know that the center of the circle, in this example at least, is xc, yc. That's the coordinates. We know that the radius of the circle is portrayed by the value of r, or it can also be lowercase. We know that the starting angle is represented by theta. In addition, we have to talk about rate, and in order to get that, we're going to be using, or speed, we're going to be using the equation BP equals 2 pi. So this goes back to cosine and sine graphs, and the period in this occasion is how long it takes the point to go all the way around the circle. So you'll be provided that information, and then you solve for B. So let's set up this equation. Well, now we know that we have x of t, because we're using parametrics, and y of t. So x of t equals our radius. Sorry, it's the center point, the x value, plus the radius, cosine, our starting angle value, plus our b times t. While the y of t is our y center point, plus r sine theta plus or minus bt. We say plus or minus because we also know that the direction is dependent on the plus or minus. So the plus insinuates counterclockwise movement. And these movements will be given to you via the use of arrows. While minus is clockwise. And this is pretty intuitive, as going negative is going negative from our initial starting point, which would typically be here, but in this case is here, while positive is going in the positive direction of degrees. So now let's do some examples. So for our first example, it'll be something very straightforward. So let's say we had a circle, and it's on our xy coordinate axes. And we're going to say that our point of interest is right here. And we'll say that this point is here at time equals 0 and when time equals 2 pi. We're going to indicate direction through the use of these arrows, so we know it's going to be going negative. In addition, we're going to know the radius is 3. So you're welcome to pause the video and try this out for yourself, but we're going to use our equation that we just derived. So x of t equals our radius, which is 3, cosine, our starting angle. So from our initial point from here, this is a 90 degrees, but we always use radian for here. So that's equal to pi over 2, because pi is 180. So pi over 2 minus t. Now there's no b value because it takes us 2 pi seconds to get around the circle. And then our y of t will be 3 sine pi over 2. And if you really want just to understand that there is a b value there, it is 1. But for our purposes, you don't need to include that. Let's try something a little more difficult. In this example, we're also still going to have a circle, except this time we're not going to be on an axis. We're going to be at an angle. And you'll see what I mean in a second. So we're going to say our point of interest is right here. And we're going to still say it takes 0, it'll be here at 0, and it'll be here at 2 pi seconds. And we're going to say that this angle right here is 45 degrees. In addition, we're going to say that our radius is 2. Alright, now we have enough information to set this up. You're welcome to pause this video and try if you like. Alright, now we're going to do our same equation. We have our radius times cosine. And in this situation, it's not pi over 2, but it's 45 degrees. We can do this by saying 45 degrees is times pi over 180. So we get a pi over 4. So now we know it's pi over 4. And since it's going positive, it'll be plus t. And then the same for y of t, except it'll be 2 sine pi over 4 plus t. Alright, in this example, it's going to appear different, but in reality, it's exactly the same. So we have our circle once again. We have our circle, but instead this time we're not going to have axes. We're just going to say this is the center point, and it's at 0, 0. So technically it is the origin, but we're not going to denote the axes. So now we're going to pick a point right here, and we're saying that this is at -2, -2. And that t, our time, because it's our point of interest, it'll be here at 0, and it'll be here at pi. So while this may look initially confusing, there's something really important here to recall. So we can first draw in a right triangle to our imaginary axes. And since this is -2, -2, we know it went 2 over in this direction and 2 down. So while you might be unsure at first what to do here, recall that we have special right triangles. So we know that when we have two sides of equal length, they form an isosceles triangle. But because it's a right triangle, we know even more. So we know from our 45, 45, 90 triangle, with alpha in this case being 45, that this side over here is √2. Therefore, in our situation, alpha will represent our 45-degree angle there. This will also be 45 degrees. This will be 90. And therefore, we have 2√2. Now that gives us our radius. So that's pretty much what we need, but there's also one last thing that we need to look at. So we have BP equals 2 pi. Notice in the last problems, we didn't have to even touch this because it took 2 pi seconds. In this situation, it takes pi seconds. So we have B times pi equals 2 pi. So B is actually equal to 2 in this situation. And we're going to say that the direction of rotation is this way. Alright, so now before we go to assemble our formula, we need to look at what is our theta. So here's our initial starting point that we're taking as a reference from. So we have to look from here all the way to there. This is our theta value. So we know 45 degrees is also 4 pi over 4. And since we know that 4 pi over 4 is 180, we know that this theta value is going to equal 5 pi over 4. Now let's assemble. Now we have enough information to assemble our parametrics. So we have our x of t equals. So we know that we have our radius of 2 root 2, which we found using the 45, 90 degree triangle. Then we have our cosine. We have our angle, which is 5 pi over 4. And since we're going in the positive direction, going counterclockwise, we have plus 2t. And since our center point is still at 0, 0, we don't have to bother with that. And then finally, y of t is equal to 2 root 2, except it'll be sine, same 5 pi over 4 plus 2t. We're going to do one more example, and this one is probably the hardest one, so I recommend that you try to do it on your own first by pausing the video. So let's take a look at it. So we're going to have our circle. Then instead of having our points, we're just going to have a line going through it. So we'll give it the center point. We'll say the center point is right here. And we'll say it's at 0, 0. So technically it is on our xy coordinate plane, but we're just going to look at it like this. We're going to be given the information that this is at time equals 0 and 4 pi. And that the direction of movement is this way. In addition, we're going to be giving this point right here on the circle, which is equal to 0, negative 10 as its coordinates. I recommend you pause the video right now and give it a shot. Alright, now that you've given it a try, we're first going to draw in a line right there. So this value right here is going to be our theta. Equation of this line is y equals root 3x. Alright, so now we're going to look at it. So since this has the same exact x coordinate, we know that it's a difference of 10, therefore our radius is 10. Also, if you recall from trigonometry, tangent function is equal to opposite over adjacent. And a handy way to remember that is from SOHCAHTOA. So we know that, opposite over adjacent is essentially equal to our slope, because change in y over change in x. So now if we take the inverse tan of our slope of this line, which is root 3, we get 60 degrees, which equals our theta value. Hopefully that makes sense. So now we're going to look at our BP. So we have our BP equals 2 pi. So our B is what we're solving for. We know our P is the 4 pi, because that's how long it takes to go around the circle one time. And we now have it equal to 2 pi. So in this situation, B is equal to 1/2. And the last thing that before we assemble our equation, we know that 60 degrees is equal to pi over 3, because that is 180 divided by 3. Now we have enough information to assemble our equations. So x of t, we're just going to equal our 10, because the radius, cosine. And now in the parentheses, we're going to have our angle deviation, so pi over 3. And since we're going negative, we have our minus 1/2, which is our b value, t. And then we're going to do the same exact thing, except we're going to replace the cosine with sine. Hopefully that makes sense, but this will be our final answer in this situation. In the next video, we're going to be looking at points around the circle, but instead of having constant motion, they're going to have variable motion. And they may not go around the circle completely. So we're going to look at that next time.